Hi, my name is Pranam Venkata. I'm a computer science senior at New York Tech.
Hi, I'm Logan Edwards. I'm an electrical and computer engineer freshman at New York Tech.
Hi, my name is Skyline. I'm a mechanical engineering student here at New York Tech.
Hi, my name is Winston Wang. I'm a mechanical engineering senior here at New York Tech.
And this is our 2024-2025 NYSID CREATE competition entry in close collaboration with Spectrum Designs.
Spectrum Designs is a nonprofit custom apparel company with a social mission to create meaningful and inclusive employment and vocational training opportunities for people in a neurodiverse world.
Spectrum Designs creates custom apparel using a widely accepted method known as screen printing for imprinting logos and designs. Screen printing uses a special type of solution known as plastisoil ink.
This ink has a high viscosity that requires equipment to be long lasting and durable. Currently, the employees are using a drill with a whisk attachment. This tends to burn the drill out and create a very messy work environment. See the pictures that we took at their facility. Trust us, it gets everywhere.
So how do we solve this problem?
Introducing the BlendBot ink
Mixer.
mixer. Our team has created a device to carefully mix the ink while thoroughly incorporating any colors in the mixture of a 5-gallon bucket. There are also 3 whisking attachments at varying heights to thoroughly mix the ink.
The appliance covers the entirety of the top of the bucket to ensure a safe and clean process. Not only that, but we added a window to ensure that the user can observe the entire procedure.
The user can adjust the speed and duration of the device. It is powered by an 18-volt battery and a motor strong enough to mix the ink, lowering the viscosity.
To secure onto the bucket, we attached 4 adjustable clamps that will lock onto any 5-gallon bucket. This prevents spillage and any movement, which will increase the safety of the workers. This device is efficient and user-friendly. The first step in using the device is attaching the lid onto a paint bucket containing the viscous ink. For demonstrative purposes only, we will be using water. To secure the device, use the 4 clamps to adhere to the bucket. Next, turn on the power by pulling on the switch on the side of the battery closest to the window. You will know the device is activated when the LEDs and the circular screen are on. Next, use the handheld controller and rotate the dial to control the speed and direction. Finally, hold down the side of the controller and start mixing and release when finished. Once complete, turn off the power by pulling the switch on the opposite side of the battery.
The first conceptual design of the BlendBot mixer featured a rudimentary whisking tool, heating coils, screw-on clamps, and a motor mount. The clamps, which were adjustable via screw, would hold the lid in place during operation. The first BlendBot lid featured mounting for a DC motor, IBD2 motor drivers, a circuit board, a voltage converter, and the battery. Additionally, a new clamp mount was designed to be fitted onto the flat aluminum disc. Following revisions featured a viewing port for observing the ink mixing process. Holes were cut out from the lid to allow for shaft clamps, screws, and rods. Additionally, a safety switch was designed to allow for battery power access. Lastly, a new electronics cover was designed to allow for exposure to the viewing port. The final iteration featured mounting for an LCD screen, slots for LEDs, and a carrying handle. Furthermore, 2 wired controlling systems were designed. The second wired controller was modeled after a CNC switch. This featured a spring-activated lever, a rotating disc, and a port for wired connections. This design was safer because it would only operate as long as the lever was held down.
After careful research and consideration, we decided to use a planetary gear system with 3 whisking attachments at varying heights to thoroughly mix the ink. We had various iterations of the gears, and at first we decided on a simple yet effective design of 1 planetary gear system with 3 whisking attachments. They were more thin and easily susceptible to breakage and had high failure points. We tackled this by increasing the thickness of the gears and adding a layer of support to hold the gears in place. Ultimately, we circled back to creating more simple yet reliable gears with 1 planetary gear system. This consists of 1 sun gear, 3 planetary gears, and an outer ring gear. The wheels are centered to add more control and the chuck to hold them in place. They can easily be detachable by unscrewing 2 screws and reapplying the new wheels in. We also added a lazy Susan for added support and less stress on the overall system.
All of our electronics are powered by a single 18-volt Milwaukee battery, which, yes, is the same battery Spectrum Designs is currently using with their drills to mix the Plastisoil ink. The 18 volts from the battery is then converted to 12 and 5 volts through the use of 2 separate voltage regulators. The 5 volts powers the Raspberry Pi Pico, which is the brains of the operation, and the 12 volts powers our high torque motor. Our main method to control the motor is through a toggle button. When the button is pressed, it tells the Raspberry Pi Pico to send a signal to an IBT2 motor controller, which translates the signal and powers our high torque motor. As previously mentioned, Spectrum Designs is currently using a drill to mix this Plastisoil ink. Using a drill to mix the ink causes the drill to burn out and is also very, very messy. The motor used in this design allows for a longer life due to its high torque and more efficient power control. After our visit to Spectrum Design's facility and talking to the staff that would be using the mixer, we modified the electrical design to adjust for each user. After talking to the staff about the controls, they requested variable speed and direction control for the motor. In this circuit iteration, we added a rotary encoder, which allows for easy control of both speed and direction of the motor. We also added an LCD display, which shows the speed and direction of the motor to make it more user-friendly. At the Spectrum Designs visit, they also mentioned how they would like staff members to be present at the mixer rather than turn it on and walk away. To account for this, we added a safety feature which includes a momentary button which allows for the motor to only turn on when someone is holding it down.